Hi everyone, I'm James. I lead developer relations at a company called 12 Labs. We are building, I believe, one of the most powerful video intelligence platforms on the planet. And today, I'm super excited to share with the audience, a shift that's happening right now in video AI that I think will change the way we build video applications forever, which is video intelligence is going agentic. So let's start with a pretty simple observation. Video is everywhere. It's how we learn, how we teach, how we remember. But also one of the most, I believe, underutilized modalities that we like to use in the modern AI stack. So with the improvement in technologies to film, store, and stream video content, we see that up to 80–90% of the world's data is going to be in video by the end of 2025. However, the infrastructure that we build to handle this form of content is quite brittle. It's built for tagging frames, not for understanding stories. And actually, this is quite a huge bottleneck, and it's holding us back. And to be even more specific, right, most video tools today relies on either predefined labels or rudimentary image text matching. And you get very generic concepts like a cat sitting on the couch, for example, without understanding why that scene matters. And as a result of that, tagging is very slow and inconsistent, where search is quite shallow. And we also see there's work that try to apply large language model to understand video. But the issue here is they only rely on picking at a few frames in video per second, making them pretty much useless for real-time video understanding. And I guess the main point is that we've been trying to squeeze video as a format into text on image, and it just doesn't fit. So at 12 Labs, we've been building multimodal foundation models that can see and reason about video like no other AI, allow us to set a standard for a new era of video data interaction. And to be more specific, our first model called Morango is a video embedding model that can convert image, text, audio, and video into numerical representation called vector embeddings. And these vector embeddings enable unsurpassed information retrieval. You can do different activities from recommendation system, hybrid search, to anomaly detection at unprecedented scale. And secondly, our video language model is called Pegasus, allows you to understand video and generate accurate description analysis. It leverages the same vector embedding space from Morango, and therefore it can answer question, generate creative output, and provide detailed analysis of any video. I want to point out another pretty interesting shift happening currently in the large language model, which is that we are making a huge leap moving from static models to interactive agents. These kind of agents can understand your goals, plan multi-step actions, use tools, and even reflect on mistakes. Some of the advanced agent frameworks like OpenAI Agent SDK, Leda, or LangGraph have emerged as some of the critical infrastructure, providing structured approach for building reliable agents. And these frameworks bring essential capabilities, including planning to integration, memory management, and self-reflection. Additionally, the fields also have become much more mature and come up with some of the key design patterns for building agent success. They include task decomposition, recursive reasoning, tool augmentation, and human-in-the-loop collaboration. And these patterns work across different domains, establishing core principles for effective agent design. So what's pretty interesting is that the key insight, like if some of these patterns and capabilities works for language, then it can probably work for video as well. However, the big difference is that video is more than language, right? So it's spatial, it's temporal, and it's multimodal. It carries sounds, motion, narrative structures, and it unfolds over time. I believe that a true video agent need to reason across multiple timescales, from frames to scene to entire stories. It needs to integrate vision, audio, and sound all together, and it needs to do so efficiently at scale. So generic LLM agent just doesn't cut it. We need some sort of video native agents that can work well, that video. So you've seen here on the slide a couple of the interesting academic work that I dig out that making a step forward in building video agents. So for example, Agent is a work from, I believe, Tsinghua University that come up with an interesting solution for these challenges by combining multimodal RAG with divide and concurrent reasoning approach. On the top right is Stanford paper on video agent that basically explore efficient searching and aggregation of relevant information from lengthy video. And then bottom right, we have a pretty interesting work called Lavi from University of Toronto that essentially combines LLM reasoning with video editing tools. At 12 Labs, we've been building a video agent framework called Jockey, which is designed from the ground up for this new paradigm. And under the hood, it orchestrates our Morango model for multimodal video search and Pegasus model for video reasoning and video-to-text generation. And we also leverage a very well-known library called FMPEG for intelligence video editing. And together, they are coordinated by a planner, worker, reflector architectures that allows Jockey to break down high-level tasks, code the right tools, and maintain context across multi-step workflows. It's like having a video assistant that can listen, think, and execute all at machine speed. Going a bit deeper into how we design Jockey. So creating an effective video agents present very unique engineering challenges that is specific to video manipulation that go beyond typical LLM application. And a big challenge here that we have to deal with, which is performance optimization in video processing pipeline, particularly for some of the more complex operations like clip combination and clip extraction. And so the approach that we've taken here is twofold. Number one is to designing asynchronous processing pipeline using function dispatchers that can handle discrete steps independently. And secondly, exposing this processing stage to users through our transparent thinking state shown in the interface. And I want to emphasize that this transparency isn't just about like status update. It's also about building essential trust by revealing how the agent reached its conclusion, showing which processing components are being leveraged at each moment. Traditional video interface typically force users to choose between either a text-based search that ignore visual context or video players with minimal interactive capabilities. So with Jockey, we reimagine this relationship through a fundamentally multimodal interface that combines conversational interaction with video native elements, treating both of these modalities as first-class citizens rather than forcing one to accommodate the other. So shown here in the slide, you can see how we demonstrate this multimodal interface approach. We have a conversational area that can capture user intent through natural language. On the bottom, we have a visual thinking display that can reveal the agent reasoning process. And then on the right side, we have a video galleries that present results with relevant context like timestamp and description. So what makes this approach very powerful is the bidirectional flow of information between text and visual element. So the screenshot on the left shows how Jockey display agent thinking step along timestamp video segment, helping users to understand not just what content was found, but why it was selected. And additionally, the interface on the right side here allows users to reduce cognitive load, allowing it to maintain context when working with multiple video simultaneously. So let me show you what this unlock. One of our customers called MLSE, which is the entertainment company behind the Toronto Raptors and Toronto Maple Leafs, used Jockey to build personalized highlight reels in 9 minutes. And that is down from 16 hours. So they just didn't save time. They actually changed the whole creative process. At the moment, they're generating dozens of personal edits for fans in real time. And this is what happened when you bring agentic intelligence into production. So I want to conclude my talk with a couple of slides looking forward to the future. This is just to get started, but our roadmap for this video agent is built around 3 core principles. Number one is flow-aware planning, where the agent can anticipate your next move and prepare asset in advance. In practice, this means that Jockey will predict which clip might be needed next during highlight creation, suggest appropriate transition based on content, and pre-assemble wrap cuts that align with the user's editing patterns. The second principle is called contextual meta learning. So the system can learn your preferences and adapt the style and pacing over time. So this means that create a virtuous cycle where Jockey can become more valuable over time, remembering specific requirements of the editing and adapting to feedback. And finally, multimodal orchestration. This means that it can combine video, audio, image, and text, and editing into a seamless generation and editing workflow. So if you're a developer working with videos, I would love to hear from you. If you, drowning in footage, building a lot of video content and excited about trying out some solution that allows you to quickly get more valuable asset from your video better, then I would love to, for you to try and sign up for our early access program. You can simply scan this QR code and, sign up and trying out and being part of the video agent revolution. Thank you.
Great talk, James.
Thank you so much.
Thank you. Got a question to ask you. So you talk about this incredible technology. Have you looked into, in terms of looking at past videos that have been archived to try and fix all the rags and hallucinations in those videos from the past? And what about in the future? Like when we look at space videos, for example, there's a lot of mess out there. Would you be able to use this technology in the future to try and even make sense of what we see out there in space?
Yeah, I mean, absolutely. Thanks for your very insightful question. In terms of past archive, we definitely have customer, have huge amount of archive, right? Whether it's in the news industry or entertainment, or even like like TV, television, creator economy, right? And they, been using our technology to basically search for like some exact moment that is so valuable in the content that they couldn't find with just like manual like editing or manual tagging, right? So it's just ability to find like clips, moments, right, from massive amount of video archive. I think that's like a huge time block and a lot of like saving in terms of both money and time for them. In terms of looking at the future, right? Yeah, space video is super interesting. I think we actually did some demos with some organization who like trying out this kind of video. They try to educate students about physics, right? And so like bring up some videos from NASA explaining how the universe works, explaining where's Mars, for instance, right? But in the past, like to get insights from these videos, students have to basically watch through like pretty long lectures, right, to understand all the content. Right. With our technology, they can just literally like prompt the AI and like get like a detailed summary, so description about what's happening in that scene, right? So that allows like the end users to consume that video much faster, more efficient, and also like in this case learn the concept more efficiently and more intelligently as well.
Great, thank you so much. Fantastic.
For sure.
Thank you.